Good afternoon. Today we're going to take a look at properties of real numbers, and tomorrow we'll get into properties of exponents. So today we're going to classify most of the numbers that you know of in your math career, so to speak, so far. We'll break those down into different subsets and then take a look at some examples. And then in the next couple of days, we'll take a look at properties of exponents. So let's get started by labeling our subsets of real numbers. All of the numbers that you know of so far fall under this big subset of numbers called real numbers. So we have natural numbers, whole numbers, integers, rational numbers, and irrational numbers. So those are all the different types of numbers that fall under this big category of real numbers. Natural numbers start at the number 1, and they're not decimals or fractions, but they're the numbers that you learned like way back in kindergarten. So they're like 1, 2, 3, 4, 5, 6, 7, 8, etc., and so on. So 10, 11, 100, 2000, 57, all those numbers are natural numbers. No decimals, no fractions. Whole numbers are pretty much the natural numbers, except for they include the number 1. The number 0. So whole numbers are 0, 1, 2, 3, 4, etc., etc., etc. So whole numbers start at 0, and then they continue on with the natural numbers. Again, no decimals, no fractions, no negative numbers. Integers are the numbers on a number line. If you maybe think back to when you were plotting like the open circle and the closed circle, and then you were shading in between different things, those are the integers. So integers are -3, -2, -1, 0, 1, 2, 3, ... Okay. So they go on and on this way in the negative direction. So -4, -5, -6. And they continue on this direction, 4, 5, 6, 7, 8. So they're the natural numbers and their opposites. -7, +7. -8, +8. No decimals, no fractions. So integers I like to think of them as the numbers on a number line. Rational numbers can be expressed as a fraction. So rational numbers can be expressed as a fraction. Rational numbers can be expressed as a fraction. So some examples, there's infinitely many examples out there, but some examples that I'm going to write down would be like 1/2 would be an example. 5/3 is an example. Even actually the number 7, even though 7 you might think, well, that's not in fraction form. But remember, all whole numbers can be written as 7/1. So in parentheses here, I'm going to say that this is 7/1. So 7 is a rational number. I can write it as 7/1. We just wouldn't put the denominator of 1 because we know that's understood to be there. Same thing with -5. I could put -5/1. That still would be a rational number. So all of my whole numbers and natural numbers and integers, I can write as a rational number. I could just put a denominator of 1. We just wouldn't do that. And irrational numbers, as you probably can think of, they are the opposite. They cannot be expressed as a fraction. So can't be expressed as a fraction. The most famous example of an irrational number that you probably know is the number pi. So pi is an irrational number. So I wrote out pi right there. Pi is an irrational number. Most of your square roots are irrational numbers. So square root of 2, square root of 7, square root of 5. Most of the square roots are irrational numbers. You can't terminate those. Like the decimal just keeps going on. Nothing repeats itself. And later on in your math life, you'll learn about the number E. So E is also an irrational number. It's 2.71, etc., etc. You can type it in Desmos. But this is actually a number when we start to talk about continuous exponential growth and things like that. So E is actually a number, and it's an irrational number specifically. So I have this little diagram down here. We're going to fill it in. We're going to start with the big umbrella, break it into the smaller subsets, even smaller, even smaller, even smaller. So all of the numbers that you know of so far, they are real numbers. So that's our big overlying category. They are real numbers. Underneath a real number, you can break it up into a rational number or an irrational number. And there's some examples up above that we just wrote down. So real is the big umbrella that everything falls underneath of. Then we have rational numbers, or you can have an irrational number. Underneath a rational number, the next subset that you can have is an integer. So I can have integer. Underneath an integer, you can have a whole number. And then underneath a whole number, you can have a natural number. So this means if a number is an integer, it's also a rational number and it's also a real number. If a number is a natural number, it's also a whole number, it's also an integer, it's also a rational number, and it's also a real number. If a number is irrational, it is also a real number. So rational numbers have many subsets, irrational numbers don't, but all of these numbers fall underneath real numbers. Now let's get into some examples. Okay, so let's start with the first example. Example 1 says, list all of the numbers from the given set that are natural, whole, integers, rational, irrational, and real. So if I'm looking at the first category, they want us to list all of the natural numbers. Now, if I'm looking up here, it may not be as obvious what the natural number is. So I'm going to go through, and the square root of 81 can be broken down. So I'm going to change that number to 9. And I'm gonna probably just change this one to put it in a fraction form so I can see it a little easier. So I'm gonna change this one to 3/5. So you do not have to do that. Just trying to change them all to something that I'm comfortable looking at and things like that, so that when I start to label them, I'll know what goes where. So my only natural number up here is the square root of 81. Keep in mind, natural numbers start at 1 and they go up 2, 3, 4, 5. No decimals, no fractions. So my only natural number is the square root of 81. Category B says list all the whole numbers. Okay, my whole numbers are 0 and the square root of 81. Whole numbers start at 0 and then they work their way up. And I put that in the wrong spot. That is the C spot. My apologies. This goes over here. Okay, hopefully you are writing in pencil as you should. Normally when I do my videos, I write in pen so you can just see it a little better. But hopefully you are writing in pencil. C says list all the integers. So my integers up here are -7, 0, and the square root of 81. So my integers are -7, 0, and the square root of 81. D wants me to list all the rational numbers. Rational numbers can be expressed in fraction form, and there's a whole lot of them up here. I got -7. I got -3/4. 0 is a rational number. I got 0.6, 7.3, and the square root of 81. So all of these numbers are rational numbers because I can express them in fraction form. -7/1. This one definitely is a fraction. 0/1. This 0.6 is 6/10. That's 6/10. This 7.3 is 73/100. This is 730/100, but it's still a fraction form. And the square root of 81 is 9. I can write that as 9/1. So all of these I can be written as a fraction. E tells me to list all the irrational numbers. That would be the square root of 5 and pi. And then F wants me to list all of the real numbers. Real numbers are all of them. So I'm just going to say all of them. So we're listing out our different categories: natural, whole, integers, rational, irrational, and real. Okay, let's do another example. We'll go through and label the different categories. The first category wants me to list all of my natural numbers. Looking up here, natural numbers start at the number 1, no decimals, no fractions. There are no natural numbers. B wants me to list all the whole numbers. So none of these, that's a fraction, it's a decimal, irrational number. So B, none of these are whole numbers. C wants me to list all the integers. The only integer up here is -9. D wants me to list all the rational numbers, so numbers that I can express in fraction form. So I got -1.3. 1/2 definitely is in fraction form. 1/4 definitely is in fraction form. And -9 I can write as -9/1. So that is a rational number. E wants me to list all the irrational numbers. Most of your square roots are irrational numbers, so this is the square root of 10. And F wants me to list all the real numbers, which would be all of them. So there we went through and we categorized all of the numbers, natural, whole, integers, rational, irrational, and real. Lastly, I want to end up, we have some examples down here. Some of these are going to have infinitely many solutions to them. So you may think of one number, your neighbor may think of another, somebody else might think of another. So, and that's okay. So we just got to read through and make sure we give a number based off of the characteristics. So it says, give an example of a whole number that is not a natural number. There's only one whole number that is not a natural number, and that number is 0. Whole numbers start at 0, 1, 2, 3, 4, 5, 6. Natural numbers start at 1, 1, 2, 3, 4, 5, 6. Next one, it says, give an example of a rational number that is not an integer. So a rational number, I can express it in fraction form, but it's not an integer, meaning it's not like -3 or +3, -4 or +4. Those are integers. So there are so many different answers to this one. The first one that popped in my mind was 1/2. But if you put 3/4, 5/7, 10 11s, anything like that, all of those would be examples of rational numbers that are not an integer. Give an example of a number that is an integer but not a natural number. Again, there's infinitely many solutions to this one. -4, -5, -2. It would have to be a negative because natural numbers are positive. So if I'm giving something that's not a natural number, it would have to be a negative. So just make sure your number has a negative. And the last one, give an example of a number that is a real number but not rational. So if it's not rational, it's irrational. And the most famous one that we probably know of is pi. So if you put a square root there, square root of 2, square root of 7, square root of 11, those are fine as well, just as long as it was a real number but not a rational number.